All right, this is the second topic on the network on AWS, and this topic is network security on AWS. So once you attach or you make your VPC publicly accessible, then there comes with some challenges. And because this VPC is now accessible from the public, which comprises of legitimate user and bad actors. So those legitimate users, they can use your resources and you don't have problem. But what about the bad guys or the bad actors or the bad users? Well, they too can have access to your resources because you have it publicly accessible. A bad guys or the bad actor, they will not show you that they are bad from the outside. They will come in like a normal human being, normal legitimate users. But it is after they are in your house or in your network, then they will now show their intent. So in order for us to protect our VPC, there are multiple resources that AWS provide for us to use. And the first thing you want to do once you make your VPC or once you create a VPC, either you make it public or not, the first thing you want to do, you want to enable a service called VPC flow log. The VPC flow log is a service, is a monitoring tools that monitors everything or every traffic that comes in into your VPC or goes out from your VPC. It monitors the traffic in your VPC. So the way to use it is once you create VPC flow log, it is attached to the VPC. You can attach it at the VPC level, or you can attach a VPC flow log and configure it to only monitor a specific subnet. So meaning that you can attach it at a subnet level, or you can attach it as an interface level, meaning that it only monitor an interface. For example, you can use a VPC flow log to only monitor a server, an interface for a server. But the best option is to let your VPC flow log monitor the whole internet, the whole VPC, meaning that you should attach it at the VPC level. So the VPC flow log is an AWS VPC feature that enables you to capture information about the IP traffic going to or coming from network interface in your VPC. So your VPC flow log, you can send the traffic that your VPC flow log gathered. You can send those log to either CloudWatch log or your S3 buckets, or you can send it to Amazon Kinesis data host, which send that data to another third-party resources like Splunk. So the first option, I repeat, is to enable a VPC flow log. And I said you can create a VPC flow log at the VPC level or subnet level or interface level, but the best option is to let it run at the subnet, at the VPC level. So once you have your VPC flow log enabled, is that all? No, there are more to what we can do. The bad actors, they want to come in and they will do anything. They can pretend to be a legitimate user. So the VPC flow log will not stop them. We only monitor that somebody comes in and somebody goes out and the network interface that they communicated to. But what if we can have a service that can actually block a bad actor. Maybe for the first time, the person comes in and he hack you or he do something bad, and you now know like, okay, anybody that is coming from this country, they don't have good intent for my site, or maybe a specific IP address that the bad actor has already used in the past. You can say, okay, this IP address is the one that hacked me or is the one that disrupts my network. I'm going to block the IP address so that nobody will be able to use the IP address to communicate to my resources. And that is how it is possible for some application to block some country that you say, hey, I'm in this country and I can't access this application. It's because they block the entire IP address, or they block that country, any traffic that is coming from that country. So you can also block an hacker using a service that AWS provide, which is a firewall, but a firewall on the subnet level called network access control list. A network access control list is a service that once you create it, then you have to attach it or associate it with the subnet that you want to use it. You can create one network access control list and attach it to multiple subnets, but a network access control list run at the subnet level. You must know that. It's run at the subnet level, so you attach it to your subnets. Once a network access control list is monitoring a subnet or is attached to a subnet, it will start filtering traffic that are coming in and traffic that are going out. So if I block a specific IP address from the networks, if I give the network access control list a rule that say, hey, I don't want anybody to access my server from maybe from what country can I use? Maybe I don't want anybody to access my server from Russia. Guess what? I can block the whole IP address that is originating from Russia. I can block a specific IP address too. Like, okay, this IP address has actually tried to hack me in the past. I can block this IP address too. So anybody, if this hacker is using this IP address, it will not be able to communicate to my resources. It won't be able to communicate to my resources. So that is the benefit of network access control list. And one thing that you should know about network access control list, it can block from coming in, it can also block from going out. Meaning that when the traffic is coming in into your network, into your VP, into your subnet, it will check that traffic, it will filter it. And if that same traffic is going out again, it will also filter it. And that is why a network access control list is referred to as a stateless firewall, because it does not remember anything. Once you are coming in, it check. Once you are going out, it's also check. It does not matter whether, oh, this traffic, is one that comes in. So because it's already coming before and it was checked and it will be allowed to go out, it doesn't do that. It forgets the state of the traffic. It doesn't know the state of the traffic when the traffic comes in, when it goes out. It just makes sure that whenever the traffic is coming in, it filter it, and once it is allowed to come in, it comes in. And once it is going out, it check again. Just like if you go to maybe church, club, or wherever, if you are coming in, they search you. But if you are going out, they don't search. But in some organization, like maybe all these organizations that are producing highly quality, maybe those people that are printing cash or something like that, if you are coming in, they will search your bag. Make sure that you don't come with illegal substance or device. And when you are going out too, they check you. So that is more like a stateless firewall because they don't know the state of your possession or your incoming or outgoing. When you come in, they search you. When you're going out, they search you. That is stateless. But if you come in, they search you, and if you're going out, they don't search you. That is stateful. So a network access control list is a stateless firewall. If you are coming in, it search you. If you're going out, it search you. So if you're coming in, it filter. If you're going out, it filter as well. So a network access control list, which is normally called ACL, network ACL, is a virtual firewall that controls inbound and outbound. Look at that, inbound and outbound traffic at the subnet level. And instead of this control, I can put it like filter inbound and outbound traffic at the subnet level. So your AWS account comes with a default network access control list that allow all inbound and all outbound. When you create your AWS account, AWS automatically or by default, they create a VPC for you. That VPC, anything that you deploy inside the subnet of that VPC that AWS created for you is publicly accessible. They don't have private because everything is made easy for you to be able to access it over the internet. And that VPC also comes with some VPC components. It comes with subnet, which means all the subnets inside that VPC, they are publicly accessible. It comes with routable. The routable too is publicly accessible. It comes with network access control list. The routes or the rules in the network access control list, all of them are allowed. And it has a general denial, but any traffic can come in and can go out because it is generally allowed. If you create your own custom control access, if you create your own custom access control list, it is fully blocked. It's automatically denied. Everything is denied. Then if you want to allow something, then you have to configure it to allow specific thing. So when you create a VPC, it comes with a default ACL that also allow all inbound and outbound traffic, but you can modify it. So there are three types of ACL now, how you can create an ACL. Once you create your AWS account, let's start here. Once you create your AWS account, a VPC comes with it. And that VPC have a ACL, network ACL. And that network ACL is all allowed, both inbound and outbound is all allowed. When you create a custom VPC, that is VPC that you create, not the one that comes with your AWS account. When you create a custom VPC, it also comes with an ACL, and that is also allowed. All of them is allowed. Then the third way is that you can create your own network ACL, a standalone network ACL by itself. And this standalone network ACL is all denied. It doesn't have any allow. This one is all allow, and this one too is all allow. So that meaning that if you do not modify anything here, it will not block any traffic. If you do not modify anything here, it will not block any traffic. But here, if you do not modify anything, all traffic will be blocked by default. So for you to allow traffic, you have to allow it. And when we get to the hands-on, you can watch the video and go and do the hands-on. But I want to explain the theoretical part first before you get to the hands-on. But you, when you are watching this video, listen to this and do the hands-on. Then once you do the hands-on, then come back and watch the video again so it make more meaning for you or to you. So you can create your own custom ACL. And as I said earlier, is a stateless firewall. This, because in an interview, they will ask you what is the difference between network ACL and security group. One of the things that must come in your answer is this, that a network ACL is stateless, security group is stateful. It's a must, it must come in. Because that's one of the things that differentiate them. One of the most important things that differentiate them. And another thing that differentiates them is that the network access control is at the subnet level, while security group at the network interface level or resources level. So the next one is security group. Unlike network ACL, security group monitors the resources and not the network. Security group monitor resources and not the network. Network ACL monitors the network. So that if you create a network ACL, it monitors the entire subnet, and everything inside that subnet are subjected to check. But security group only for specific resources. So when you create a security group, you need to assign it to the resources that you want the security group to be monitoring or to be protecting. You can create one security group and attach it or use it for multiple resources. Not all the resources on AWS you can use security groups to monitor. There are some, especially those ones that have an interface that use an IP address. Then you can use network ACL to monitor them. I mean, you can use security group to monitor them. So your security group is a firewall, a virtual firewall for an Amazon EC2. Not only Amazon EC2 instance, you can use it for load balancer, you can use it for relational database and multiple things too. But I think this topic is old. I mean, this presentation is old, so I might modify that later. So by default, the security groups deny all inbound and outbound. Okay, by default, a security group denies all inbound and allow all outbound. Yeah. So if you create a security group, by default, it denies everything. Or it denies all the inbound, but allow all the outbound. So you can modify your security group for specific thing that you want to allow or you want to deny. One thing that also differentiates security group from network ACL is that network ACL check both the inbound and outbound, which is the stateless. And you can configure both the inbound. If you configure both, if you configure it, you have to configure the inbound and the outbound. But security group, it's only work with allow. You can only set what you want to allow. But network ACL, you have to set what you want to allow. You can set what you want to allow and set what you want to deny. But security group, you can only set what you want to allow. There's no space for you to deny anything. But anything that you do not allow, they are implicitly denied. And security group is a firewall, is a stateful firewall. So here is our network ACL. And look at how it works. You have a network, you have a subnet. Here, you have a subnet. And that subnet, you can protect it with network ACL. Once you are protecting a network, if you are protecting a subnet with a network ACL, you can create a rule to allow. You can also create a rule to deny. Once you create a rule to deny or allow, you can specify that I want to deny port 22. So anybody that is trying to connect from port 22, they will not be able to connect. You can specify that you want to deny port 80. So anybody that's connecting through the web browser, they will not be able to connect. And the same thing with 443. And when you are connecting, when you are specifying this rule, you have to create them like in numbers. You can say number one rule is port 22. Number one rule is port 22, deny. Number two rule is port 80, deny. Number three rule, port 443, deny. But the problem is this: if there is a rules that you want to put like here, then you won't be able to put it because you cannot use 1.5. Because the way network ACL check this rule, it starts from the top and it goes next. It goes next. If it does not find any what it's looking for here, then you go next. But immediately it find what is looking here. Immediately we find what is looking here. Excuse me. Immediately you find what is looking here. You may not be able to input another one inside this middle place. So that is why it's always advisable to use like 100, 200, 300. So in case in future time there's something to put in between, you can do 101, 102, and 103, something like that. So it's always good for changing like that. Oh, somebody raised hand. Please that you can unmute and talk.
Yes, I was about to ask that because this looks to be like the same as a security group. On what is the difference between using a network access control list and using the security group, and at what point do we use those?
Did you just join the class?
Lost my network and
Okay, because I actually explained that. I explained that earlier that I gave like 3 different cases that differentiate them and when you can use them. So the network access control list is a firewall at the subnet level, and you can set both allow and deny rules, and it's a stateless. While security group is at the resource level. Inside this subnet, you can have multiple resources. Like you can have like 5 web server. You can have a container. You can have a container here. You can have other like RDS database. So any resources inside this subnet, if any other resources want to communicate to any one of them, it has to pass through the network ACL before it can get here. But when we are talking about security group, it's only monitor that specific service or resources alone. So if it is a security group now, well, the security group will just come. Once the traffic pass through here, then we still have to come here to these resources before the security group can go into effect. If the traffic does not come to these resources that is being protected by security group, then the security group has nothing to worry about.
Okay.
And here is also some different, if you can see from the topic, this is the difference between network ACL and security groups. So I will take 1 minute back to quickly re-explain this. So I said at the top level, your network ACL is at the subnet level. It monitor or it checks traffic at the subnet level. That is for the network ACL. Then it's also you can set both allow and deny traffic or rules. So when you set a network ACL, rules, the rules will start from the top. As you can see here, they evaluate rules in order, and they start with the lowest when making a decision about the traffic. So you're going to start from the top. SSH, allow or deny. Port 28, port 80, deny. Port 443, deny. Like I said before that question comes in, if you have multiple rules, let's say you have 1, 2, 3, 4, and you already say port 80, deny. port 443, deny. Port 22, deny. If you want to add something here, you won't be able to add it because there is no space. And you might want to put something here, maybe because the way the system, the ACL will check the traffic, it will start from here. It's not starting from here. It will start from here. Is the traffic allowed? Let's assume that you want port 3349 to be allowed. It will start from here. Is this port 33443? You say no. Then, okay, let me use port 80. Let's say you want to check port 80. Remember, your number 1, you already put port 80 here, deny. And number 5, you put port 80, allow. It's going to start from the top. It will check port 80, deny. That is the end. It's not going to check the remaining for this for port 80. It's not going there. So that is why if you are putting your rules, you need to be mindful of this number, or it check in order. It puts into consideration your arrangements of your rules. You can say I put allow here. So assuming that it's checking now, it will check here, port 80, deny. Then you can still say, oh, let me check the remaining. Maybe there is an allow somewhere by checking port 2, port 3, port 4. And when you get to port 5, say, oh, there is an allow. I'm going to allow it. No, it doesn't do that. Once you check the first rule that it meets, here, and you say deny, that is the end. It's not going to check the remaining for this. It's not going to check the remaining rules for that same. It's not going to check the remaining rules for that same traffic or ports. So here now, you can see any other one that you do not specify, it will put it asterisk as deny. That is by default. It will put it as asterisk, which means every other traffic is denied. If you want to allow a specific traffic, this is how it's going. You can say port 22 deny, port 80 allow. So if a traffic is coming from port 80, let's assume that there is a folder or a traffic that is coming from the browser on port 80, is going to be allowed to come inside the network. But if it is not coming from port 80, maybe the traffic is coming from port 22, it will be denied. So now let's go further to look at the second security group, the second firewall, which is security group. With security group, you're going to have a service like a resources like this, like a web server, and the security group monitor that web server alone. You can create one security group to monitor multiple resources, but what I'm saying in essence is that it actually operates at the resource level, not at the subnet level. So it filters traffic for this instance. And when we talk about security group, you can only allow. You cannot set your deny rules. You can see under ACL, network ACL, we are setting deny rule. But in security group, you cannot set deny rule. It's only what you want to allow that you just specify. I want to allow port 80, you specify it. I want to allow port 22, you specify it. Every other thing that you do not specify, they are implicitly denied. So if you allow port 80, and if the traffic is coming from port 80 from your customer, it will be allowed by the security group. Every other thing will be denied. So this is the end for this network section of the AWS cloud. So let me see, do we have more time to go to jump to the console? I'm going to stop the video here. And if you are watching this video, there is going to be a hands-on section. So just check for it in the playlist.